restart the recording here. All right, so let's do better tools to do this. First better tool is to create an augmented matrix. So for an augmented matrix, we are going to take the coefficients. First row in my augmented matrix is 2, -2, 2. And then to remind myself that the stuff on the right is on the right-hand side, I'm going to draw a vertical line, and that gives me a 0. So my columns on this matrix are C1, C2, C3, and then the other column is the right-hand side. Okay. Next row is going to be 2, 0, -2, and then 0. And then my last row is 1, 1, 1, and 4. So this is my augmented matrix. It's called augmented because it has the extra part on the right-hand side. This is the augmented part right here, this part on the right-hand side. And now what I want to do is turn this into a triangular matrix. So everything down below the main diagonal, that part, I would like to zero out. Everything below the main diagonal, I would like to zero out. If you have taken linear algebra, you can kind of half listen to me in the background while you work through this on your own. If you haven't had me for linear algebra, hang with me and we'll work through this together. So, elementary row operations. I can do elementary row operations. Here's my notation. What I want to do is zero out this 2 and this 1 first. I'm trying to zero out everything in this block right down here, but I want to zero out the 2 and the 1 first. So here's my notation. -2 row 1 plus row 2 gets sent to row 2. That will let me zero out this 2 right here, right? If I multiply -2 row 1, let's try negative row 1, sorry, negative row 1 plus row 2 gets sent to row 2. Negative row 1 plus row 2 is going to zero out that first entry. And then I'm going to do 2 steps at once. I can also do -1/2 row 1 plus row 3 is going to get sent to row 3, because that will zero out the 1 down here. Everybody seeing it who hasn't taken linear algebra? Do we see where that's coming from? Let me write it out and I'll see if that makes sense. So first row doesn't change. I've still got 2, -2, 2, 0. For the second row, I have to multiply the first row by -1 and add. So that's going to be a 0. -1 times this plus this gives me a 2. -1 times this plus this, I'm not sure if you're watching and that's okay, we'll try. -1 times this plus this gives me a -4, and then I still have a 0. Okay, and then the last one, I'm gonna get 0, 2, 0, and 4. Okay, checking my math. Please check my math. People who have linear algebra know they absolutely positively have to check my math because this is a really good spot for me to screw up. All right. Yes, we're happy. We're good. Questions, Stuart? What did I screw up? It's entirely possible.
I don't know if you screwed up or anything, but I'm just wondering. So, what is the row? Is that's what's going across?
Yep, rows are going across. So
okay.
This.
I just wanted to confirm.
Yep, this is row 2 and this is row 3. Grant,
okay.
Question. Yes.
Can you explain the last row one more time for me?
This one right here?
Yeah.
This operation.
Like how you got the 0, 2, 0.
Oh, sure. So -1 times the first row plus the third row.
Oh, okay.
Okay. So -1/2, I'm sorry. -1/2 times the first row plus the third row.
Yeah.
So -1/2 times this is +1. Add to +1, I get +2. -1 added to 1 gives me 0. And then I still have a 4 down here. Okay. People who have taken linear algebra can go get coffee or something because I'm sure you're done and that's okay because people who haven't, it's not a prereq for this class. The last thing I have to zero out is this 2 down here. So I also want to make sure to keep these zeros. What that means is I don't want to use row 1, because if I use row 1, I'm going to reintroduce a non-zero element here, and that is a problem. I would like to keep these zeroed out. So we're going to use row 2 instead to zero this one out, because then I will keep these zeros here as well. So this is going to be a negative row 2 plus row 3, and that's going to get sent to row 3. Negative 2 row 2 plus row 3 gets sent to row 3. We'll draw an arrow up here. So row 1 isn't changing. That stays the same. 2, negative 2, 2, 0. Row 2 isn't changing. That stays the same. 0, 2, negative 4, 0. And then I'm going to have 0, 0, 4, 4. And I'm writing my headings underneath instead of above because I don't think I have enough space above. C1, C2, C3, right-hand side. So I'm going to start at the bottom and work up, and hopefully this has let me found my coefficients. So third row now turns into 4C3 equals 4. Technically, 0C1 plus 0C2 plus 4C3 equals 4. Basically, that gives me my value of C3. I can say that C3 equals 1. Yay, that's good. I have one of my coefficients. Second row, moving up, 2C2 minus 4C3 equals 0. 2C2 minus 4C3 equals 0. If you do some quick mental math, you can solve for C2, and it turns out that C2 should equal 2. So if you do some mental math, you can get to your C2. C2 equals 2. And then row 1, 2C1 minus 2C2 plus 2C3 equals 0. That's the equation that comes out of row 1. And once again, we know C3, we know C2, so we can plug in, and it turns out that C1 equals 1. C1 equals 1. Okay, stopping sharing. People who have had linear algebra, you really could have gone and got coffee if you wanted to, because like I said, we did this umpteen bazillion times last semester. People who have not had linear algebra, give me a thumbs up. This makes sense. We're seeing where this comes from. Yes, cool. Okay, by the way, you've now got a little bit of a head start on linear algebra too, because we're going to do this a lot in there. You'll probably forget it by that point in time, but at least it'll be vaguely familiar when we come back to linear algebra. All right, so here's what that did for us. Remember what we had. We had that our vector x was C1 vector x1 plus C2 vector x2 plus C3 vector x3, right? I didn't write it that way, but we put it that way in the matrix. So this is going to be 1 vector x1 plus 2 vector x2 plus 1 vector x3. I just found my coefficients. I know what my coefficients are. I totally found them. And what I can do then is write out my solution. So function x1 of t is 2 e to the t minus 4 e to the 3t plus 2 e to the 5t. I'm going to back up a slide just a second, show you where that's coming from, and also make sure that I did it correctly. 2 e to the t minus 4 e to the 3t plus 2 e to the 5t. Backing up a slide, right? Our vector x, or our function x1, was 2c1 e to the t, c1's equal to 1, minus 2c2 e to the 3t, c2 is equal to 2, plus 2c3 e to the 5t, and c3 is equal to 1. So plugging in those values for c1, c2, c3 gives me coefficients of 2, -4, and +2. Okay, I just overly simplified. I can get function x2 of t. So x2 of t is equal to 2e to the t plus minus 2e to the 5t. Plugging in those coefficients, plugging in c1, c2, c3, and x3 of t is e to the t plus 2e to the 3t plus e to the 5t. Plugging in those coefficients. This is where I really wish stuff was on the board because I'm having to go back on my paper and it's not immediately on the board, and it would be way easier if it were immediately on the board for me. That is a solution to the system of differential equations because it's 3 functions, and it is a particular solution because there are no unspecified constants. And it meets the initial conditions. Remember your initial conditions. x1 of 0 equals 0. x2 of 0 equals 0, x3 of 0 equals 4. You should be able to do some really quick mental math and make sure that all of those work out. x1 of 0 equals 0, x2 of 0 equals 0, x3 of 0 equals 4. Really, really quick mental math, and all of those are going to work out for you. Okay, let's pause screen sharing for a minute and see if there are questions. Are there questions at this point in time? Anything? Stuart, yeah.
I have one, but I think it might be something like I think most people understand, so I could just maybe ask it after class.
You're fine. Go ahead and ask. You're okay.
Oh, okay. So I'm just confused with the augmenting matrix.
Yep.
How you figure out what rows to use, or like negative, how do you know that negative row 1 plus row 2 equals row 2?
Yep. So your goal is, so first of all, you want to make it triangular. So you're trying to zero out everything in this block right here. That part makes sense?
Okay.
Okay.
Yeah.
And so, yep, you want to always start at the top and work down. So we want to start at the top and work down, and we want to start at the left and work to the right. Okay.
Okay.
So I want to start at the top, work down. I want to zero out these 2 entries. So what do I have to multiply this entry by so that when I add it to this entry, I'm going to get 0?
-1. Okay.
Exactly. What do I have to multiply? And I did 2 steps at once.
Sure.
What do I have to multiply this entry by so when I add it to this entry, I get 0?
-1. Okay, that makes
Yep.
a lot of sense.
Yep. Yes.
It's just like, where is that coming from?
Right. No, it's,
Okay.
yeah. If I were working on the board, it would be easier.
Okay.
Other questions? Other questions on this? Not a lot of differential equations. A lot of linear algebra, but not a lot of differential equations. Other questions? Seth really did go get coffee. All right. Other ones? Okay then, one more thing for today, and then we will be done, and we're probably going to be done early.